Okay, so let's start. So first of all, you guys can make your account, build your account on Kaggle. Okay, this is actually very important. So this is the Kaggle account. You can just directly you have to go to the www.kaggle.com and you have to just sign in with your Gmail. That's it. And here you will see the home page and there's a competition. So whatever the competitions are going on, so it will show. You can see here if I'll click on the competitions. So see, these are the competitions are going on. This is the prize money. Okay, so you can see this is so and the data sets. So for the practice for the beginners, advanced or intermediate level, this is one of the best. So these are the trending data sets. Psycho, uh, social dimension of student life, something, and the penguin sizes data set. So there are multiple data sets are there. So you can go through this and you can try to explore. So today I had just picked one data set so that you guys can understand. So how to come to this page? So you have to, let's suppose you chose one data set like this, something like house rent prediction data set, okay, or the house price. So you just click on this and just click on the new notebook. As you will click on the new notebook, it will automatically bring you to this page. Okay, so now let's jump to our problem statement and try to understand. So we will, so whenever uh, you start any machine learning or any AI based problem, you first need to understand the entire data. Okay, you need to understand that. So here I am reading this data. I can see here. So these are the columns. So what this all column stands for and what it is. So here I had just written the explanation. So CRIM is the crime rate per capita by town. ZN is the proportion of residential land zoned for lots over 25,000 square feet. So these are the some definitions. The proportion of acres for business not connected to retail trade in the town. So these are. So what we have to predict. So this is mid V. It is the median value of owner occupied homes in thousand of US dollar. This is, so this is 24,000 US dollar, 21.6 thousand US dollar based on the given features of the house. Okay, given condition of the house. Now, what is the task? The task for this data set is to predict target variable mid V. This is median property value using the following features. All except mid V, because this one we need to predict, so we can use only these. So the first is we have to check the info. Info, it will tell. So this is the way from pandas to read the CSV file. So this is the path of the CSV file. When you are doing it from your local, you can use that as it is. When you are not doing it with your local, you can directly from here, when you run, you will get this path. Okay, and you just copy paste here. So when you do so I read it in the variable named as df, and when you do df.info, see, this is the things will come. So what is all information it is saying. So there are total 506 records, okay, total, and which are indexed from the 0 to 505. So it has started with the 0. Okay, how many columns are there? So total 14 columns were there, and these all are the 14 column details. You can see for this, let's take this column. So it is saying in 506, all 506 are non-null, means there is a not a single null value present in that column, and this column data type is float. So when you say something is float, so this one how this pandas actually understand. Two things you guys have to understand. See this. So whenever any decimal kind of value will be there in the column. One second, guys, one second. Okay, so how it understood. If suppose in this is your data frame, this is your data frame, if suppose, and then these are the columns, column 1, column 2, and column 3. So if this has value 4, 10, 13, 12.7, something 100 to 32, something here is written ABC, hello, or something like Sydney. So this is the integer type. By default, it will take 64. 64 is the bit size. This is the float, because here the decimal is 12.7. In spite of two values are integer, but because of one float, it will read it as an float. And this is, it read it as an object. Object means categorical, the descriptive. So if I will come to the solution here, you can see here. So though there is a no any object type, otherwise it would have shown. Now, though by seeing it here, we understood there is a no null value. But if you want to check explicitly, so there is an code df.isNull.sum. If we will run, see that. So for the every column, it will tell is there any null value or not. Now, we have to understand, I told you one of the assumptions of the linear regression, that I told you about one of the assumptions of the linear regression, that with x and y, it should be the linear relation. So it needs linear relation. What does it mean by linear relation? If suppose this is x and this is y, either it should follow like that or it should follow like this, if this is x and y. So what is your y here? MEDV, mid price value, mid value, right? And x is your those all columns which are presents. So the question is, how would we check that? How would we check that? So for that, let's import some library. Okay, we imported here. Now sns dot think scatter plot is the, let me see, yeah, scatter plot. Now on x-axis, let's suppose one by one we will go. I want to compare with this crime. Okay, this crime, CRIM, is that a crime? Let me see, what is CRIM? The crime rate. Okay, crime, and y is our feature which we need to predict. Guys, please focus. Okay, now let's see. So what you are observing here, when this crime rate is increasing, the price is almost, see, it is decreasing. Though it is not completely linear, but somehow it is, you can see it is decreasing. Because see, between 0 to 20, when the crime rate was there, the prices has not decreased much. There might be the reason, because between 0 to 20, the crime was not so visible for the people. They were not thinking that's a huge crime, so that's why they were not recognizing it like that, and still the prices were, and people were buying it on the good prices. But as it started increasing after some certain value, means if you'll see after this value, after this value here, it is linearly decreasing. So if you want to see more by that, you can just see it. Let me show you one thing. DF of CRIM crime, and let me check its describe. So what this describe do, it gives the descriptive analysis. Descriptive means mean, median, mode, standard deviation, all those things. So here this crime has the minimum value is 0.06 and the mean value is 3, but the max value is 88. So what we will do, let's filter our data for the crime value more than, let's take the direct value from here. If crime value is more than, let's suppose 4, okay, this is 4. So I am filtering my data and I'm storing into new data. Okay, and now let's do this scatter plot on this new data and see how much linearity has changed. See that if you are seeing it here now, this is looking almost similar. The values are started decreasing as the crime. So here the few you are seeing it because here very less values were there. Okay, because as per the distribution, if you would see the describe where it went, I think I changed that. So if you would see this describe, by this describe you will able to understand that till the 75 percentile values are 3.67, but it has increased after 75 percentile. So might be till the 90 percentile it would have same. So you can quantile, quantile, you can check with the 0.9. So see the 90 percentile till it is 10.57, but see the highest values are there. So this is also, you can say this data has the outlier as well, because the majority data is lying between this and this value 0 to near to 35 or 36. But after that the values are going suddenly very high. Okay, so this is how we need to perform the analysis. Now let's understand on different feature. So crime we saw. Now let's check another feature after the crime, which is ZN. So what exactly this ZN is? The residential landed zone for lots over 25,000 square feet. What exactly this ZN is? Let me see the relation. So if you are seeing this relation, definitely this ZN is not going to be important, since this it is not showing a linear relation with the y with our predicted. We can see here the describe of that. I'm showing you guys one by one step, but once I'll share this notebook with you, I will make it in very concise way so that you do not have to go, but just to make you guys understand. So here the maximum values, all the values are looking zero. Yeah, all the values are zero. So now we can drop this column because this all the values are zero. So if you want to check, there is something called n unique. So how many unique value presented here? Sometimes it gives here like this. What happened to this code? Uh, np dot unique. So np dot unique would tell. So there is an only one unique value which is zero. So it is simply understandable. This is one of the a good example it came here. So you guys have to always someone it came. So you guys have to always think. Let's suppose if you are solving any problem, okay, if you are solving any problem and let's suppose this is your y value, y and for this condition it is, for this data set it is midway, that median price value, and let's suppose somewhere it is 100 or 24, 27 or 200. Now there are three columns, and in one column the all values are 2, 2, 2, and here it is something like 10, 120, 11, 330 something. And here something like here some values are like 0 1 0 1. Now can anyone tell me on basis of the this by looking at these three columns, which column could be the most important for this y? This one is the most important. Okay, anyone else? Which column could be the most important to predict the value of y? Anyone? Fourth one, that we need to predict. How could you include? I'm saying to to predict this y from these three, which could be the important? One answer I got for the that this one is the important. Anyone else want to give a try? See, let me tell you one thing. This is not important. Why? Logically, if you will think, this entire row for this column is not getting changed, but this price is getting changed. Means if the price would have dependent on this, by changing of this column value, this could have changed. But this is not, this is getting changed, but this one is not. It means it is not complete, it is not getting dependent on this. So that is for sure that this column is not important. And we can clearly eliminate that. So always remember this rule. If any of the, this is a step of data pre-processing or the feature engineering to select the important features. So if any of the feature or if any of the column which has the one unique value means one value is repeatedly coming in the entire record. It means that column you can drop. That is not going to add any extra information for your data or for your predictor, for your predicted column, whatever you want to predict. Now let us come to this. Now by seeing these two column, if anyone is saying, sorry. So I will come on that. So the first rule which I said, that which is not important is this first. And how would you check that? I had already showed it here. You can check the unique value. Here see only one unique value is coming. Means in the entire column there is an one value which is 0. And by the plot also. Till now I haven't come on that scenario that how would we say which one is important or which is not. Right now I'm only saying for the column which is not going to be important, and for that only one rule I had said it right now. The first rule, if there is an one unique value, one unique value in entire row of any column, then we can drop that column. This rule is universally truth. Okay, now let us see this one. Now let's see this two column, this two. Now maybe here we have only the four records. So by seeing that, maybe some people can apply some algorithm and they can say that this is important or that is important or this one is. But by seeing it from the naked eyes, do not come on the conclusion that which column is important and which is not. Only this one also I'm saying after doing analysis, or when I see that here that all the records are having the same value, then I said this is not important. But here the values are getting changed. So you cannot say, for that we need to perform the analysis. Okay. And see, your analysis, whenever you have to do the analysis, make sure one thing always, that what is your end goal, what you want to achieve. Accordingly your analysis should be. And the second is, which algorithm you are going to apply, according to that you have to perform your analysis. Let us suppose here I am trying to do linear regression. So I should know, if I would have known that the assumptions of linear regression is x and y should have the linear relation. So in my pre-processing, I will always check with my y with all this feature, whether this feature has a linear with this or not, this feature has a linear relation with this or not, this feature has a linear relation with this or not, always. And if any of the feature is showing a highly non-linear relation, then your linear regression algorithm is not going to capture the information from that feature. So now after that you have to take two steps. Either you have to change your algorithm or you have to eliminate that feature, because that is not going to add any information in that. Guys, am I clear here? How come you are saying third column is saying irrelevant? See, this is not the way you are seeing here, only the four records. That's why I'm saying it cannot be here the thousands and millions of the records you will get. So that I already mentioned that if you are seeing it here only the four record, but if you have this millions of the record, by seeing that, how can your brain and how can you come on conclusion that this is important or not? But that is the final no, that if you see that here, that if all the values are same, if you checked in your code or if you checked from the visualization that all the values are same, then directly you can say this column is not important. But here the values are not same, values are changing. So in spite of the values are changing, after that seeing that thing, though the values are changing, after that also you cannot say this is important or this is not important. You have to do further analysis. So that's why I'm not saying for any of these two columns that whether this is important or not. Okay, so for that we need to do the analysis. It is as simple as that, that I'm saying that Zn is not important, but I haven't said that for other columns that those were important or not important. So as of now, let's drop the Zn column. So I'm writing this is the function from the data frame dot drop is a function, and you have to pass axis equals to 1. Axis 1 means from the data frame I want to, and in place equals to true means from the same data frame I want to make the changes. Now when I will do this and make it head, you can see here now you will not find the Zn. So we perform on a CRIM, we saw it is related with the mid value because it is changing with the value of CRIM. Now let's check with the index. So I'm just, let me copy it from here and on a X, let's put here index and run this. Now see it here. If you will see, again this is very critical. You will see the majority of the values are only one, but there is an only one value which is different. Do you guys think that this column is going to add any information to the our predictor? Only one data point, only one point is 19.6. I'll show that. If you want to verify validate this, you can just do this and you will write here greater than 18. Okay, and sorry, this is df1 I'm using here. Okay, this is df I have to use. Yeah, no, this is as the value. I was using different data frame. So when you are seeing it here now, with Indus and Midway, now there are lot many value, but if you would see, majority are getting changed like this. Majorities are getting changed. See this. If you just imagine a straight line like this, it is getting, means with the increase of Indus, this value of the house is getting changed. Now what is Indus? Let us check that what Indus is. The proportion of acres for business not connected to retail trade in the town, and that is uh, definitely a correct and logical. Means this is those area which are not connected to the retail trade in the town. So if definitely those area will increase, that house price will get decrease. So that's what it is showing it here, and it's logical, and it will add the information because it is also has the linear relation also. With the increasing index, this value is getting decrease. Everyone, please ask and say if any questions you have. Okay. Now let's come to the next column, which is called CHAS, a dummy variable indicating if the plot is bounded by the Charles River. 1 if bounded and 0 otherwise. Okay. Now, by seeing this, you can see it here that it has only the two values, 1 and 0. So logically, it should be a categorical value. But if you see it here, the model has read it as an integer. Now that's our responsibility to make the model to understand it is an categorical. So I'll come on that. How would you do that? So let's do the performance or check with this. So here, uh, it is saying a dummy indicating if the plot is bounded by the Charles River, if it's the nearby a plot is nearby with the river, Charles River. So let's check this. So now you can see 0 and 1. So by this, you can see it cannot be more visible. I'll tell SNS dot. For that, we can use this one box plot, and x is equals to, this is the entire part we can put. So this, from here you will get better understanding. You can see here. So 1 means what? Bounded. See that. See, and it's logical, maybe might be that because of that environment, or so if the house plot is bounded with the river, their price is higher. See, see, this is 1 is the bounded plot, 0 is not bounded plot, and it is adding the information. You can see it here. This one, their minimum price, you can see how much it is, and see this minimum price is very low, but this minimum price is even much more higher if the plot is bounded with river. And this center line which you are seeing, that this is called the mean value, average value, and this is called the quantile Q3. This is Q1, or you can say that this is 25 percentile, this is 75 percentile, this is the 50 percentile, and this is called the max value, and this is called the mean value. And whatever the point will go beyond to the max values and mean value, those are called outliers. Means here it is outlier, means there are very few points which has the higher value here. You can see the maximum values are matching, but here there are very few points as this, but here there are lot many points. Okay, so this is adding the information. Make sense, guys? Now let's see the next column. NOx. So NOx is a nitric oxide concentration in parts per 10 million. So according to you, with nitric oxide, what should be the price relation? Let's see. Yeah, when it is increasing parts per billion, it is decreasing. But if you would see, uh, with some certain values, it is constant till 0.6 or 0.65. It is constant till this here, till here. But after that, when it is increasing, that this price has started decreasing. Okay, so we will see now, or we will do the analysis further, and you have to keep in your mind that what was the factor by which, if the nitric oxides are has increased from 0.4 to 0.6, still the prices are constant. But these are, you can see, these are for the few peoples. Okay, but the majority is decreasing. You can see this majority area. Majority is linearly decreasing. Make sense? Now let's come to the next column. RM. Average number of rooms per dwelling. What it is, this dwelling? Let's see the RM. What exactly it is. So when RM is increasing, average rooms, I think rooms are understood. Average number of rooms. So average number of rooms, if it is increasing, the price is increasing. See that it is highly linear. You can see this is highly linear. Okay. Now age. So the proportion of owner occupied unit built prior to 1940. So usually you can understand it as an age of a house. So let us see uh, what is the information with the age of the house. See, if the age of a house is increasing, it is decreasing. Okay, but for the few people, their price might be constant because of the, might be they were at the what I can say, at river bounded. Yeah, I mean there could be the multiple factors. It could be, or their number of rooms were higher on those. Okay, those are the older room, or maybe their square feet areas or some things are higher. That's why. So it could be the multiple factor which we will see. Now this is here DIS, weighted distances of to 5 Boston Employment Center. So that is again, if it will decrease, the price will decrease. DIS probably. See, when it is decreasing, the price is decreasing. Okay. Uh, DIS, if it is increasing for the sum, and the price is increasing. You can see it here. That is how it is. DIS, distance to 5 Boston. When it is increasing, weighted distances, index of sex. So this is how you can check. Now let's come directly to our model building pipeline. So why I'm saying, because this is the way you have to do the analysis. You have to keep the feature, or you have to remove the feature. You have to understand which algorithm I have to apply. Let's suppose it is regression, and now there is a no linear relationship it is coming. Then you will have to not select a linear regression model for that, because that will not going to perform well. So you have to understand it from the analysis, which algorithm you have to apply, which feature is important, and do I need to make the new values from that feature, like that. Now